Thank you.
Ah, ah, ah.
All right, let's start the session. Good afternoon, everyone. Hope all are doing well. Um, just before we start, I want to notify everybody that from now onwards, we are going to have our sessions on this platform, uh, Blackboard Collaborate Ultra. And before the session, I'm going to create separate sessions for each class we are going to have. So maybe 5-10 minutes before the session, new link would be created, and you can always click on it and join the session. Now, I would appreciate if you don't distribute this link to any outsiders. Um, and we have seen few incidences, and not only in our class, in many other sessions. And this is completely not tolerable, and it is not good. So I would appreciate if you all don't share this with anyone as such, because students who are in the class, they can themselves log in and click on this collaborate and enter our session. That's what I wanted to discuss before we start. Thank you all very much for joining. So let me uh, start recording the session today, and I'm going to share my screen. Um, um, could you all quickly tell me that can you see this screen? Yes, perfect. Now, um, thank you. Um, I guess, could you all quickly tell me which slide number we were on? I guess we have gone through this. Uh, mm, okay, so let's uh, right. Okay, I guess we are around this slide, if I'm not mistaken. Correct? All right. So in this, we have already seen that how we can create a um, uh, basic environment as far as Visual Basic is concerned, and we saw how we can drop uh, different uh, tool tools from the toolbox into our working platform as far as Visual Basic is concerned. Now, we learned also that there are two separate screen, one for design, which is the front end, and the one in the back end is the programming part, which we need to write our instructions to be able to manipulate the front end as we require. So let me instantiate Visual Studio. So we know that Visual Studio is a platform which consists of many. We can, invoke many programming languages. One such is Visual Basic. Now we click on New, and if you want to create a new application, you go to New and click on Project. Now I have many basic softwares which I've already downloaded under this environment, but uh, the language which we are going to program in this course is Visual Basic. So we are going to click on Visual Basic and click on Windows Form App.NET Framework. And let's give a name. Um, the program, say prog 1, 2, 1, say. And I'm going to say, okay. Uh, you cannot see uh, the screen of my program, right? Now, can you see this screen, the programming screen, the Visual Basic? Okay. Now, let me see how I can. Okay. Now, that's interesting because I have to see how I can share um, the programming mm, environment on it. Okay. Yeah, that is correct. Now, sharing the desktop. That I have to find out how I can share my um, now at this point. Can you see my screen? Okay, good. So that's very good. At least you can see the programming screen. Very good. All right. So um, going back to the now you can see the uh, PowerPoint, right? Okay. So this I have to every time switch over between uh, the so-called PowerPoint and then going back to sharing the screen. It's not versatile as such, whereby I could immediately show you um, everything at one go. So let me see again. Yeah, maybe we can do that. So I don't have to swap between the two as such, but I have to get used to this environment and see uh, how I can navigate. Uh, yeah, so every time I have to switch between the two. All right, I guess that's the only way. All right, so over here, I'm gonna click on uh, text box. So I'm gonna create two text boxes at this point and make it multi-line text boxes. So I click on this right arrow and make it multi-line so that I can make it a bit bigger horizontally and vertically. And I am going to also create a button and use this to create some instance. All right. Now over here, I'm going to maybe write some text inside my text box one. So I'm going to just write uh, Visual Basic program. And in my text box too, see now, Visual Basic has come, program has come, and over here I'm going to write programming. And I have it over here. So I'm going to change the font and make it a bit larger. So maybe I make it 14, or maybe even bigger, maybe 16. And the same I'm going to do with the next one. Make it 16 and okay. So this is my front end, and I have the so-called two boxes plus some text written in it and a button. Now let me instantiate my so this is not this is the course. Okay, now let's run this program and see what exactly it happens. Now, how this programming environment comes into picture. Now look here. If I double click on one of the text boxes, the first one, okay, it would create a page called form1.vb, and this place you can actually start writing your code. Now, few lines of code are already displayed. You have the class and you have a subroutine, and the subroutine name is textbox1. Why? Because you double clicked on your textbox1, and the name, why it is textbox1, because you see under properties you have textbox1 name already pre-assigned to this. You can always change it, and where you can change it in front of name. If you change this, your text box name will change to whatever you have decided. You can change any name, or you can give any name to your text box. Text boxes, even you can change name of your buttons, list boxes, doesn't matter. But by default, when you create them, initially they would have a given name assigned to them. Now, the first one is text box 1. You see the second one is text box 2, and your button has name button 1. So I'm just going to keep it as it is. And you see my subroutines name is also text box 1. Now we know the subroutines are created for each of those tools, and each subroutine is embedded in a given class. Now you see the class's name is named after form. This form1, is the place where your tools are. So your form1 is your class, and all these tools are going to be individual subroutines. Now, at this point, I can write an instruction which would do some manipulations of your text box 1. So what we'll do, we'll try to change the color of a text written in your text box 1. How can we do that? We are going to just copy this instruction. And where I'm going to copy it, just inside my subroutine. Now you see, text first, there is a problem. You see, the problem is that it says text first is not declared. It may be inaccessible due to its protection. No, it is not. Why? Because I don't have such a name for my text box. My text box name is text box 1. So I'm going to just copy this as the name of text box one because we don't have a text box named txt first. Now you see that problem is gone. And what this line says that the foreground color of my text box one, which actually says VB program, would change its color to be blue. So at this time, it has a black VB program. The text has a black color. But when I run my program or execute my program, in other words, the color of this text would change to blue. Now, how can I run this or execute the program? First, we go through more, one way, and I'll show you how you can go through an easier way. Now, this is where my program would be given to the compiler to check if I have any syntactical errors, which we talked. So any grammatical mistakes I have done would be shown to me when I say build solution. I can do the same thing by just, so let's see. So there is no problem. You see, I have no problem. I have the program succeeded and nothing has failed. So once you have, you see your program is syntactically free of error. Either you can do that or just press F7. Now you go to debug and press start without debugging or control F5. Either of the two would now execute your program. Now you see the text on your text box one has changed its color from black to blue. Now, what happens if I change this to say red? When I run the program, so every time you change, you have to again build or compile your code and then run because it's a new instruction. Now you see it has changed to red. So at this time, I'm just changing the color of the text in my text box. Now let's see how I can use this button to do the same thing. Now in this case, my button is redundant. You see, when I click it, nothing happens. So why I brought it here? Let's make a use of this button and see how we can do the same thing, but instead of just directly displaying the text in a different color, we use the button to do the same thing. So what I mean by that, I'm going to now erase this and go back to my design. And now I want to write the code in such a way that when I want to press the button, it would change the color of the given text in a given text box. So for that, I have to double click on the button and inside my subroutine button, write the code. Now this is, let me actually copy it from here and change the name. Xverse to Xbox. Now you see, when I run my program or execute my program is one and the same. The text in the text box one still remains as black. Why? Because now the command I have written is not in the text box one. It is in my button subroutine. So I have to trigger or instantiate the button by clicking it. And once I click, then it would run through and would take this instruction and would do the necessary by changing the color to blue. So now, when I build the program, I see there is no problem. When I run, you see, when we ran the program previously, the color was already changed. But at this time, the color is still black. But now, look here, when I click the button, it should run the program and change the color to blue. So when I clicked it, it changed it. Why? Because I wrote the command in my subroutine button. Now I'm going to change the color. You see, when I put the first letter, there are many such different options come. Let's put purple. And this time I want to change the text by clicking button and make it purple instead. So I just run the program, and this time when I run, you see nothing happens at this time because the button has to be triggered. So when I click it, you see it has changed to purple. So right. So this was a very simple program to execute, and it would clearly show you how we can use the form to design and the programming screen created to be able to give instructions to change and manipulate what we have in our design page. Now, there are these particular screens in your so if I go here, you see everything comes. So you can manually change the colors if you want from backend for front color or back color. As such, this is one way. So basically, you can do that. So if you see over here, and if you remember, you could always manually change the foreground color to any color you want, right? But today we wrote a program to do so. So that was manual if you wanted. Otherwise, you can write a program to do so. So click this button to return to Form Designer. So this one is for Form Designer window, and the other one is for Form Designer, and this is for your program. And you can navigate through both these screens. Now, you can double click on the red button to return to the code editor and add outline and event procedures. And we have seen that, how we can do it. Now look here. Now we use both button and the text and see what happens. So I have put two text boxes. One is this one and one is this one. Now I have used button for my text one. I'm not going to use a button for text two. And this time I'm going to copy this and change this to blue. This time I'm going to make my text box 2. To see what happens when I execute this program, what will happen? Text box 2 would change the color of programming course, because I have a text in my text box 2, which is programming course. That would be changed to blue as soon as I execute. Then I would click on the button and change the color of the text VB program, which is in my text box 1 to purple. So you see, in this program, it does clearly show that we can directly access the text box and do some manipulation, or use a button to do that. So in this case, for changing the color of my text box 1, I use a button. For my text box 2, I don't use anything because I wrote the instruction in the subroutine of text box 2 itself. So programming course would directly change its color to blue, but for VB program, I need to use a button to change the color because I wrote it in my button. And the action would be to click the button to change the color. Now, you can either go through the steps as I showed you, build solution, and everything is okay. Once you have one succeed and no failed, and run the code, see what happens. Directly programming course, you see, it has changed the color to blue. But for VB program, it is just waiting for you to click the button to change the color to purple. Okay. Now, if you want the button to do both these actions, what you would do, you just bring this and put it in the button itself and remove this. So now you can do either that, or as I said, there is a shortcut by just pressing start. When you start, it would compile and run. Now you see both these are waiting for the button. Now, as soon as I click the button, VB program would change its color to purple, and programming course would change its color to blue. You see? So I use the button to trigger and do both the changes. But I could have written, as I did, one of them in the text box itself. But I brought it to outside and put it in my button one. So this is how we can write the program in a different way as well. Now, event procedure text first dot leave, you select text first. Now, these are the names your textbook is giving to the text boxes. I have not changed the name. I could have changed, but I left it as what the default was. You can always change it as anything you want, doesn't matter. So select text first on the form, click on the event button in the properties window, and double click on leave. So basically, when you do that, you can, over here, your text first, the leave would change its color to black. The text box first would change it to blue. And when you click the button, the text would change to red. Okay. Now, let me show you another program. So let me just copy this, and I'm going to delete this and go back to my form and just click on my text box one. And now and go back and click on button and copy the same thing, and instead of this put blue. Both are doing something with text box one. Now look here, when I run the program, the color of VB program would change to purple directly because I have put in this instruction in my text box subroutine. And when I click the button, the purple would change its color to blue because again, the text box I have used, but this time I have used the button. So let's execute the program. You see now the color has changed to purple. And when I click the button, it will change it to blue. Okay. So this time I've used the same text box, but I have written a code or instruction to change the color to purple as the program executes, because I wrote the code inside the text box, so it would take it as it is running or executing, and it would wait for you to click the button, and that would go through the second subroutine and changes the color from purple, which was done during execution, to blue. All right. So basically, this is showing that this is the name of your subroutine, which can be changed as the same we said that even your design tools, doesn't matter whether it's text box, list box, or button, also can change their names. And the name of your subroutine also is an optional. You can change it as you want. Now, what is on after handles is the event which would be triggered to do some executions inside the body of this subroutine. So over here, you have changed the button. So it says that when you press the button, click, it would maybe change the color of a given string to red. Now, an event procedure can be invoked by more than one event. So you can always use two events at a given time. So in this case, it would change the color to red, and also it would leave the session or the program. So you can instantiate two events in one execution. Now, this is just a programming funda. It says that the following work would not, the following statement does not work. Now you have a form, and in that form, if you want to display a text or basically a string, now please understand whatever is in double quotation is, it is a given string. Now form demo.text equal to demonstration, this is not a right syntax in a given Visual Basic programming environment. Instead of form demo, you have to write the keyword called me. So instead of writing the form demo, you just have to write me to be able to execute the program or store a given string as a text in your given form. Now open and run and execute existing program. Now it could happen many times that you want to retrieve back the program you have written. So where these programs or your Visual Basic programs are stored, you click on File. Instead of New, we click on Open. Now you click on Project and Solution, and it will take you to a folder. Now it depends upon your laptop where these files are stored. It will take you to that particular folder, and you are going to search for the program which you want to open. So basically, Uh, these are my VB programs. So I double click on this, and the programming file, which when you click, it would take you to the Visual Basic environment and would give you the program which you were looking for, is having an extension .sln. That is a solution where your code is. Now I'm not going to double click it because it takes me out of this program and takes me to another program. But once you click this, it will take you to the programming environment where you have written your. So solution is the file. So basically click on Open Project in the File menu, navigate to the Programs folder, double click on the Programs folder to open it, and double click on the file with extension .sln, which stands for solution. In the Solution Explorer, you can double click on the file with extension VB, and this will take you to the form designer as such. Then you can press F5 to run the given program. Now, with this, we have concluded with chapter 2. Let's start with chapter 3. Now, chapter 3 is already uploaded for you in your course shell, and all of you all have an access to it. Any questions anybody has at this point of time? The midterm is going to be in the week of 7th. So we are going to talk about it a week before the midterm. So it's around week 7. That's normally mid of the semester. Yes, assignments are going to be uploaded soon. I'm going to prompt you about it. We are only going to use Visual Basic. We are not going to use C#. No C#, only Visual Basic. Okay. Any other questions before we start the next chapter? All right. So let's start with chapter 3, and let's see what are variables, inputs, and outputs. Now, generally, the types of data we enter into our systems are of either numeric values. Non-numeric values are broken down into integers or double or float types, which have fractions. They could be either characters, they could be either strings. So there are few types of values which we are able to enter from the keyboard into our systems. Now, they could be numeric values, and numeric values could either be integers, the pure straightforward integers like 1, 2, 3, minus 1,000, 1 million, or they could be of type double or float, for example, 1.5, 23.60, minus 23.05. So these are double or floating point numbers where you have an integral value and a fraction part. So let me tell you what I mean by integral and fraction. All right, now integer values could be of this type. So any, even 0 is an integer value. So integers are just pure, simple numeric values. Now double types are numbers which have fractions. Now, this number 40.5 consists of 40, which is the integer part or integral part, and a fraction part, which is 5. And you have string data types. And we know strings are always enclosed in a given double quotations. So book is a string, A is a string, because both lie under a double quotation. 16 is an integer, but when you put it in a double quotation, it loses its identity from integer to be a string because it is in double quotation. All right? So these are few types of data. We have in Visual Basic another data type called decimal, which we are going to talk about it in this chapter as well. So these are few data types. Any data you enter should be the format should be one of these formats, either integers, double, string, or decimal. And you need to always clearly mention in your program which of these data types you are referring to, because the compiler should know what kind of data it has to grab and put it in a given memory location. Now we are going to talk about what is a memory location and what are the characteristics of a given memory location and how a given value can be stored in that memory location. Now, we are going to talk about arithmetic operators or arithmetic operations. Now, arithmetic operations, how they are taken into consideration. Now, most of the arithmetic operations, we know using arithmetic operators, plus, minus, multiplication, division, and this is exponentiation. So an example of this could be 2 raised to 3, or basically 2 raised to 3. You don't have to write it up. Two raised to 3. This would give you 8. Okay, these are arithmetic operators which can do arithmetic operations. We are going to talk about other kind of operators like relational operators and logical operators. But we are going to talk about them as we go through the lecture slides. So we have seen arithmetic operations. Using arithmetic operators, you can say 2 plus 5, 2 minus 5, 2 into 5, or 2 divided by 5, or 2 raised to 5. We are going to see what are variables, what are augmented assignments, mathematical functions, and the integer data type. Also, there are two other integer operators which we are going to talk about later. We are going to talk about decimal data type. I just told you that we are going to talk about it, and this is that decimal data type. We are going to talk about multiple declaration, how it could be put in a given expression. We are going to talk about brackets and how brackets play an important role in the order of precedence in a given expression which contains multiple operations. We are going to talk about three kinds of errors which normally we programmers would commit, and also the error list window where all the errors are listed, where it is and how it is going to be taken into consideration. So error list of windows. And now, having said this, arithmetic operations, as we just talked, there are 5 such operators which can do operations: plus, minus, multiplication, division, and exponentiation. Now look at this. First one is clear, 2 plus 3, 5. Now 3 into 4 plus 5. We're going to talk about this in a minute. And 2 raised to 3 is 8. Now let's talk about 3 into 4 into 5. Now 3 into 4 plus 5. Now, what's the difference between this and 3 into 4 plus 5? What is this value equal to, and what is this expression equal to? Now, as far as this is concerned, are we going to do addition first and then multiplication, or are we going to multiply then add? In this case also, are we going to add first and then multiply, or first multiply and then add? That's the question. Now, the question is easily answered if we know the order of operators, precedences, rules, and regulations. Now, what the operator precedences law says. Now, these are ISO standards, and they have been predefined, and we have to obey them. Otherwise, when we write, we don't get a proper, meaningful answer out of them. In this multiplication, division have the same priority. And plus and minus have the same priority. But multiplication division have the higher priority than plus and minus. So they have a higher priority, and they have a lower priority. Now they have higher priority compared to plus and minus. So basically, when you have this expression, multiplication would be taken into consideration first. It's not because multiplication comes first. No, because of the priority. So in this case, it would be 12 plus 5, which is 70. Now, if supposing you had 3 plus 5, or maybe we can write the same, but so if you had 3 plus 4 instead of multiplied by 5, so you are swapping the operators. In this case, multiplication would have taken into consideration and the result would have been added to 3. So in this case, you get 20 plus, here you get 3. So 23, the answer. Now, why? Because multiplication has a higher priority. Now, above all the operators is the bracket. So brackets have the highest level in the operators hierarchy. So whenever you have brackets, by default, the expression in the bracket would be evaluated first. So in this case, it would evaluate this and then multiply. So it is going to give you 4 plus 5, 9 into 3. And the result will be 27. Now, why is that so? It's just because you have the brackets. Now, when you didn't have the bracket, in this case, multiplication would happen. In this case, multiplication happened. But here, since you have the bracket and brackets have the highest precedence in the operators hierarchy table, you need to first do the expression inside the bracket without caring about the operator's precedence. Now, you don't really care whether plus has higher precedence than multiplication or not. As long as it is in the bracket, it would by default be evaluated first. And then you open the bracket and multiply to the one outside. So this was as far as operator precedence's law. And when I saw this bracket, I thought I would explain to make things more clear. Now let n be a number or a numeric expression. The statement lsbox.item.add in bracket n. Now n in this case is the input parameter to your listbox.item.add. Now this would display the value of n in a given listbox. Now we're going to write a program and you would be familiar how to use a listbox in Visual Basic environment. But see, as far as text box was concerned, it was just text box. Now, I want to, in this case, you just had text box dot for color. Now, for color is the member function to text box 1. And blue is a member function to color. So the dot operator, after the dot operator, it would have the member function which correlates to a given method. So let's see how we can use a list box. So we are going to create a list box in our form designer window and create a button. And let's see what we can do with it. So I'm gonna go back to my Visual Studio, and for Visual Basic IDE, IDE is the integrated development environment where you write your programs. Now I'm gonna just remove all this and write a fresh program. Now go back to, I'm gonna just bring all this to the back and create a list box and another button. So this is my list box. And I'm gonna create a new button. Okay. So I've created. If you want, you can change the, so you see, this is the second button. I can always change the name of it to compute as we have in the slides. And maybe I can change the font. And change the color maybe. Okay. But the name of my button compute is button 1. I've just changed the text. Okay. Now let's see what we can do with this list box and the button. Now you see, it says in a given list box, now all the list boxes have their name as LST result. And this is a name given by the textbook. We can change that name to anything we want, but as long as it matches with the lines of code we write. So over here, you are going to put in a list box an item, which is 5. The next item which would be displayed is 6. And the next item displayed would be 8 minus 1, 7. So it's very simple. I'm just going to copy this. In my button compute, because when I click that button, it should display the results on the screen. So I'm going to double click this and copy those lines. Now it's going to be giving me a problem because we don't have a name called list results. The name of my button is called button 2. So what I'm going to do, I'm going to change all this to button 2. BUTTON2, BUTTON2, maybe more. Now I see there are problems. What is the problem? So items is not member of button. Uh, button. And to okay, yeah. Interesting. Why this is not working? Is there anything I'm missing? Button. Oh, yeah. What am I doing? This is, I have to put list box 1. Oh, God. It is list box 1. I have to, what I'm thinking. Sorry, this should change to list box 1, not button 1. Button 2 is the name of, so it's actually list box 1. Yeah, and this is list box 1. List box 1. I'm just displaying all this in list box 1. I don't know why I wrote button. Anyway, so everything is good because I'm displaying all this and adding into my list box 1. And this is the name of my list box 1, which I can see on the property. Right? All right. Now, when I execute, you see directly I get the values as such. Now, let me go here and go here. So when I click the compute, it would display 5, 6, and 7. You see? I click the button. And all these values were computed and displayed on the screen. Okay. All right. Now, just wanted to again emphasize, so pay attention that this is the name of the list box the book has used. I have not changed it. I could have changed it to list box or LSC result, but I had to change this. I'm sorry, this to LSC result. So if you want, I can do that as well. So I'm just going to copy this and change the name of my list box to the same name as what we have. Let's change to box. So this is now changed. And now in my program, I can run the code. You see everything is fine. Now my name is changed to list result. And when I execute the code, it would be displayed. So either you change the name, but that name should be written in your instruction in your subroutine, or you use the default naming, and if you copy and paste the program, you change that particular name of the list box or text box to what name it was defaulted at the beginning, which I did both of it. First, I changed the list box name to which was already defaulted, and I did it in the program. And second run, I changed actually the name of my list box in the design screen and ran the program perfectly okay. All right. Now, we were talking about a given value to be stored in a given memory location a while back. How a given value, which lies under one of those representations, numeric, double, decimal, or string, could be stored in a given memory location. So that would be the next topic now we are going to discuss. A numeric variable is a name to which a number can be assigned. Now, when you want to store a value should be stored in a given variable. Now, variable could be A, B, C, D, E, F, G, Z. In this case, speed, distance, interest rate, balance. So why the examples are given as such, it emphasizes that the best programming practice is that you give a meaningful name to your variable. Now, when you read a program and you see the variable name speed, you can correlate it to speed of an object or a particle or a given vehicle or any speed of a given object. Distance would be distance from A to B or X, Y, or A to Z. Interest rate would be the interest rate calculated on a given loan. And balance would be a balance of cash in a given bank account. So basically, you can correlate these names to something which we understand. But supposing I use a variable A, B, it's not that I cannot use variable names like A, B, but what do you mean by A? If I write speed equal to 200, we know that, okay, or 100 or 50 or whatever, this is a speed of a given object. But if I write A equal to 50, we don't know what is A. So it's best to name your variables which have a meaning, in the sense it gives a meaningful description to the variable as such. Now, talked about variables as how we can name them, what exactly these variables are and why they have to be declared is the next topic we are going to talk about. Now look here. In Visual Basic, you need to declare a variable like this. So you write dim, speed maybe, as integer. This is a syntactical way of declaring a variable. So this line is called declaration of a variable, in this case, speed. So the whole thing is a declaration of a variable called speed in this case. dim is a keyword which stands for dimension. So this is a keyword. Speed is the variable name, which you can decide whatever you want to name it. This is again a keyword which has to be there as a syntax, and this is the data type. This means that my speed can only store an integer value, no other data type. It cannot store doubles, it cannot store a string, it cannot store decimal. It can only store an integer. Why? Because I have declared it to be an integer. So this is a statement or a line of code which declares a variable in Visual Basic programming environment. So dim, as these are the two keywords which need to be there by default. The name of the variable, you are going to decide which name you want to give to your variable. So it is any arbitrary name you can give, preferably a meaning which can correlate to the value, and the data type is that particular format of data you are going to store in your variable. In this case, integer. Now, how can you store a value in a given variable? In this case, we have declared speed. So my speed is the name of the variable. So I simply can write the name equal to, say, 40. Now, this line is called initialization or definition. So let's talk about each one of these. This was the variable name. This is an assignment operator. And this is the value which should obey the format you have declared speed to. So we said speed can only store integer, so you can only store a given integer value into the variable speed. How? Using assignment operator. So in this case, what happens? 40 is going to be assigned to speed. Or in other words, 40 is going to be stored in the memory location of speed. Now, as far as assignment operator is concerned, always remember what is on the right of the assignment operator would be stored on what is in the left. So 40 is going to be stored in speed. If you write a statement like this, this is a wrong statement, because we said assignment operator puts what is on the left in. You cannot store something like this in 40. 40 itself is a value which has to be stored in a given memory location. So basically, you cannot say, no, I'm putting 40 to speed. No, because the assignment, the phrase assignment itself is evaluated as such. It puts the value from left to right. This is a wrong expression. Now, the first line was declaration, second is initialization. During declaration, what happens? During declaration, now, during declaration, there would be a memory location created or grabbed from RAM. Say this is a memory location. This memory location would be given name speed. It has a given size as well. So memory locations would have a given size depending upon the data type. Now, the size of this memory location would be at least 4 bytes. Why? Because integers can only store 4 bytes of data. And any given memory location has a given address. I'm just writing this as arbitrary value. It's just an address. So remember, during declaration, there would be a memory location created which has 3 components. One is the name, which is the variable name. The other one is the size of that memory location, and the size would be dictated depending upon the data type. Integers need 4 bytes. And each and every memory location would have a specific unique address. There are no 2 memory locations in RAM which would have similar addresses. Each and every memory location would have its own unique address. Okay. So this is as far as the memory location. And when we say 40 is assigned to speed or 40 is stored in speed, this is the line where you are going to put 40 in this memory location. So 40 is held in a given memory location or RAM, random access memory, which is named after speed. Now let's talk about the size, 4 bytes. What exactly does it mean? Now, normally 1 byte is equivalent to 8 bits. Now 1 bit consists of either zeros or ones. So a bit could be either 0 or 1, either. So when we say 1 byte is equal to 8 bits, that means 1 byte, its size is 8 such zeros or 1. So combination of zeros and ones, 8 such would make 1 byte. So when I say an integer can store 4 bytes, what would be the size? 1 byte is 8. 4 bytes would be 1 into 8. So an integer value can only store 32 bits, means 32 such zeros or ones. Now, it means that in this memory location, the capacity is only to accommodate 32 zeros and ones. If you go beyond 32, that particular value cannot be stored in this memory location. Now, what we mean by 32 zeros and ones? Now, hypothetically, I have written 40 in this memory location. But in reality, 40 is not going to be the value which is going to be stored in this memory location. Since computers can only understand binary language, and binary means binary language, consists of combination of zeros and ones. Right? So this 40 should be converted to its equivalent binary language, and that binary language or binary code, which consists of zeros and ones, would be stored in this memory location. And it should not exceed 32 bits, 32 zeros. Now, how we can convert 40 into its equivalent binary? That's not your job. The system would do that. But for explanation, I'm just going to convert one value, 40, to binary so that we see what is the methodology. Now, every time you have to divide the value by 2 and retain the remainder. The remainders, remember, should be either 0 or 1. So 40 divided by 2 is 20. Remainder is 0. 20 divided by 2, remainder 0, result 10. 10 divided by 2, result 0, remainder 5. 5 divided by 2, remainder 1, result 2. 2 divided by 2, remainder 0, result 1. 1 divided by 2, since we cannot divide, remainder is 1. I'm sorry, yeah, remainder 1, result 0. Now, am I going to write these remainders from top to bottom or bottom to top? The rule says that I have to write these numbers from bottom to top. So 40 as decimal, now decimal have base 10, has binary equivalent as 1 0 1 0 0 0. Right? So basically, in this memory location, what is going to be stored? It's going to be stored 1 0 1 0 0 0, which is equivalent to 40. But every time you are not going to store or convert a value into its binary and store it, you're going to put a number, and the system actually in reality would do what it has to do. But just for clarity, I wanted to explain to you that when you click and enter any value, it's not that exact value which would be stored, it's the binary equivalent to that value. All right. Now, how you can prove that 101000 is 40? You can always go from binary to decimal also. So what I'm going to do, I'm going to give an index, since these are binary, 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, and 2 raised to 5. And multiply and see what is the answer. So all zeros multiplied by this would be 0. The only thing I'm going to get is 1 into 2 raised to 3 and 1 into 2 raised to 5. This is going to be 8 and this is going to be 32. 8 plus 32 is 40. So you see, the binary equivalent to 40, I have just proven, is 101000. So this is, in a nutshell, what we mean by variable declaration and variable assignation. So when you declare a variable, in this case speed, there would be a memory location created, and that memory location would store a value, and that to only integer value because you have declared speed as an integer. And an integer value can only be stored in a given variable, in this case, speed. So the line where you write dim speed as integer, you are declaring that you have a variable named speed, and when you are giving it a value, you are initializing the variable speed, or you are defining or you are storing value in the memory location of speed. And we said each and every memory location has a size, has a name, in this case the variable name, and has a unique address. And using assignment operator, you can store a given value in the memory location, and that value should be integer, which afterwards would be converted to its equivalent binary. And we said that since integers can only store 4 bytes, the number of bits of that value should not exceed 32. All right. So maybe you cannot store 1 billion in this memory location, because if you convert 1 billion into its binary, the number of zeros and ones would, of course, exceed 32 bits. There are other types of memory locations which would, of course, be able to store bigger values, and we have to use those kind of data types. All right. So having said this, now let's go back and see when this talks about variables and declarations and initialization. Now we have a clear understanding what the slides have to say. Now, slides do not really explain all this, nor the book. I don't think so even the book goes into such details of explanation of many terms they use. So as and when I think that there are more explanation needed, I would be 100% going to my whiteboard and explaining things in more detail. All right, now I want to see if you all want a break, 5 minutes, and then we resume, or you want me to continue? Okay, take 5 minutes break and we resume at 5. Thank you. All right, let's start the lecture again. So we talked about variables, and we said that it's best to give variable names as meaningful as possible. Now, we used speed as an integer value, right? Where we set dim speed as integer. In the slides, they have used a different data type called double. And we talked about doubles, right? We said doubles can have values which have decimal part as well. So 5.6 is a double type value. But look at the declaration, the syntax of this line. You have to use dim, the name of the variable, as a given data type. And you see, as far as the assignation is concerned, it's written speed equal to 50. And we talked in detail what we mean by assignment operator and what is stored in what. So 50 is stored in speed. So basically you have to write 50 on the right of the assignment operator and the memory location or the variable name on the left. And during declaration, we said that there would be a memory location created, and using assigning or assignation, you can store a value in. So talking about initialization is the assignation, that equal sign. Now, there are two ways you can assign values. This is just matter of programming style. So you can write dim speed as double, integer, decimal, whatever, equal to 50, or you can write it this way: speed as double, but instead of writing assigning in this or declaring and assigning in the same line, you separate them into different lines. So in this case, you are assigning right after declaration. So this is declaration and initialization together. Here is separate. Declaration and initialization. So again, it's a programming style. Whichever style you prefer, you would be able to do. The only difference is that you are adding an extra line. Otherwise, in reality, or as far as the efficiency or effectiveness is concerned, both are exactly the same. Now look at this segment of code. Now let's see in Visual Basic Programming environment how you can declare, assign, and display some value in a given box. In this case, list box. Now you see they have declared a given variable balance and given a data type double, and a value is stored in it. Now let's talk about 1000. Now you see 1000 is an integer value. Why we have used double, not integer? Now let me quickly talk about this also before we write the program. Now, dim balance as double. Set integer values need 4 bytes of memory location. Double type values normally need 16 to 32, depending upon the microprocessor you are using. So you see, double needs a bigger memory location, whereas integers need lesser or smaller memory locations. So basically, an integer which needs a smaller memory location could always be stored in a double memory location. So a small value could be stored in a bigger container or memory location. But a double value, which is a big value, cannot be stored in a small container or memory location because doubles need 16 to 32 bytes. So if you want to store it under a memory location which only can store 4 bytes, it's not possible. But vice versa, if you have an integer which only needs 4 bytes, you can store 16, 20, I don't know, 50, any memory location which is bigger than 4 bytes, you can store an integer in. So therefore, when you write balance as double, there would be a memory location created for balance. Maybe it, depending upon microprocessor, so say microprocessor gives only 16 bytes, easily 1000 could be stored in it because 1000 could be stored in 4 bytes also, since it's an integer. But 16 is more than enough, and of course it can be stored in this big memory location also. So that's why they have used double. They could have used integer also, but doesn't matter as such. So you should not get confused why this value is an integer, but I am trying to declare it as double. It's just because of the capacity of the memory is much larger and easily an integer value could be stored in. All right. Now let's go back to our Visual Basic environment and let's see how we can execute this program. Now, to just give you an explanation, so 1000 is going to be stored in balance, and then you're going to multiply 1000 into 1.05. Once you multiply, the result is going to be 1050. That should be displayed in the list box called LSC box. Okay. So let's write the program. So I'm going to again remove this and go back, and under compute, I'm going to, and I've changed, of course, the name of my list box to list results, and this is also list results, so everything is fine. And oh no, but I didn't copy paste, so this is what I have to copy. See, it's list box, whereas my name of my list box is LST results. So I'm just going to change this to results. So in my list box, once I execute and press the button, it should give me 1050. So I'm going to execute the program by clicking the start. Now, you see, I'm just going to click and 1050 should be displayed in my list box. Okay. Now, I would request you all to run the program as I am working and explaining so that you also get used to the environment and get acquainted with the instructions and this programming environment. So just take a while and just run these few programs I have ran and let me know if you face any problems. So I give you a few minutes to run these programs if you have not got the chance, and run and let me know if you have any questions. Please let me know if you have any questions or any difficulties running the codes. Yes, you can do it later if it's not possible, but 100% please try to run the program so that you get acquainted with the environment and understand the concepts behind the scene. So I guess everybody had a chance to do the program. Anybody had any problems in the code? All good? Good. All right. Very good. All right. So let's continue. All right. Now let's talk about another program, and let's see how this program could be executed as such. Now, before that, let's again understand what exactly all this means. Uh, Now, var1, var2 means variable ones. So if we say dim, maybe say speed as double equal to 5, and dim, say balance, just variables, as double equal to 4, and say speed num1 they have used there, speed equal to 3 into balance, and the display. So what exactly happens over here? So you are declaring and initializing at the same time. So basically, in this case, your speed so your speed would have a memory location, say 16 bytes, since it is double, so bytes, some arbitrary address, and 5 is stored in. Balance would get its own memory location, 16 bytes, some address, and 4 is stored. Now look here what happens. It says multiply T to balance and store it in speed. So 3 into 4. Store it in speed. Now look here. Each and every memory location can only store one and only one value. Now, as we said, it's not 5 and 4 which is stored in the memory location. These are the binary values, but we are not going to every time convert. So when it's a 12, it should be stored in speed. So in this case, 5 is going to be overwritten by 12. So you're just going to multiply 3 into 4. You're not going to change 4. You are going to store the result in speed. So only speed is going to change its value. All right, remember, only assignment operator changes the value of a memory location or a variable. Here you are just multiplying and not changing the value of balance. You're just multiplying 3. Unique address also at a given point of time, it can store one and only one value. If you try to store another value in a given memory location, if you store another value into a given memory location, the previous value would be overwritten by the new value. Okay, this has to be clearly understood. Now let's run the code and see what happens. Now, why I wrote balance, you can use the same numvar1 and numvar2, doesn't matter. I just gave it a meaningful names. So I just this was the results. Basically, yeah, and you're displaying numvar1. So what would be displayed on the screen? It would be 12. So when I run the code and click on the button, 12 is going to be stored. Okay. Now, in Visual Basic and few more programming languages, we have operator shortcut. What we mean by this, let's talk about it more in details. Now, if you have a variable a and you need to add a value to it and store back in a, how you can write it? So you would write actually a equal to a plus 1. So you're going to add 1 to a and store the result in a. If you want to subtract 1 from the current value of a, this is how you do and store back in it. If you multiply, same, and if you want to divide, you do the same. Now all this could be written in a shorter form. Now please understand, over here a is an operand, plus is
an operator, and 1 is the value. Okay, so operand A, operator plus 1 is the value. How you can write it in short form? You just need to write the operand, the operator, assignment, and the value. Same here. Operand, operator, assignment, value. Operand, operator, assignment, value, assignment, operator, value. Same here. So this is a short format of writing. Now, if you want to write A equal to, or maybe use any other, maybe write, I don't know, maybe speed equal to speed multiplied by 40. This could be written as speed multiply equal to 40. All right. Or maybe Z equal to Z divided by 100. This could be written as Z divided by equal to 100. Okay. So this is a short form operator. Always write the operand, operator, assignment operator, the value. All right. So operand, operator, assignment, and the numeric expression or value. Now we have some inbuilt functions which would return a given value depending upon the function evaluation. Now we have few math functions. One such is called square root. Now look at the first one. Square root, or SQRT, is an abbreviation of square root, takes 9 as its parameter and returns back square root of that value. Now we know square root of 9 is 3. Now what is this math? Math is the library which contains this particular. So in math library, you have a code already written to compute the square root of a given number, and that program's name is SQRT. You don't have to worry or bother how that program is written, as long as you know that that exists and where it is. You know it is in math library. So you write math dot name of the function in round bracket the value which you want to compute its square root. And once you write that, the system would go and run that code and return back square root of that given value, whichever you have written, in this case 9, on the screen. Look at the second one, int 9.7. Now this int stands for integer. It means that you are, now we said that this double value is divided into two parts, integral value and decimal value or fraction. 9 is integral, 7 is fraction. So when you say int 9.7, it would extract the integral part and omit the fraction part and returns back 9 only. The next one is a round. So the parameter, what you give, 2.7, is going to be rounded up to one higher than that number. So 2.7 would be rounded up to 3 and it will be displayed on the screen. And again, this round is in your math library. Okay. So this round would take a given number, round it up to one digit higher than the integer part, which is 2, makes it 3, and displays it on the screen. So these are some predefined functions which are good to know, and we can use them to display different values on the screen. Now, integer data types, it's just telling you what is the maximum size of a given integer value. Now, variables of type double can be assigned both whole numbers and numbers with decimals. So remember, I said double values or double type memory locations have big memory locations or containers, and they can easily store integer values. Also, they can store decimals, or in the sense that value which is integer and contains some decimal values. All right, decimal values is not that what I was talking about. So integer value would be this, and each of these are digits. Okay, so that's a decimal value as such, one decimal, second, third. So the statement dim var name or variable name as integer, here this declares a numeric value that can be assigned whole number values between -2 billion to +2 billion. So the capacity of this memory location runs from -2 billion to +2 billion. Anything less or beyond 2 billion cannot be stored in this memory location. Now, integer division is basically denoted as backslash. So when you say 23 divided by 7, it would just return the result after dividing these two values. Same as 8 divided by 2, it returns 4. So integer division is similar to ordinary long division, except that remainder is discarded. You see, 23 divided by 7 is 3 point something. So that point something is going to be discarded, and only the integral part would be displayed. Okay, if you want to get that decimal value, then you have to put forward sign of division. The backward is just the integer division, which would give you the integral part, not the fraction part. Now, what is the mod operator, and why we say that 23 mod 7 is 2? Now, remember, mod returns back the remainder after dividing two integer values. Now, 23 divided by 7, you see, 23 divided by 7 is 3, 3 is 3 into 7 is 21. Remainder is going to be 2. So this is going to be given to you as a modulus or mod. So (23) mod 7 would be 2. So when you divide, remainder would be 2. So here in this case, mod is an abbreviation of modulus, and modulus returns remainder after dividing two integer values. Now 5 divided by 2, the result is 2. But 5 mod 2, result is 1. 5 divided by 3, integer division, result is 1. But 5 mod 3, remainder is 2. Okay. So here mod returns the remainder after dividing two integer values. Now look at this decimal data type. We talked about different types of data. We talked about integers, we talked about doubles, we talked about strings and decimal. Now in the program till now, we have only used integer and doubles. Now decimal values, they are declared, or this declares a numeric variable that is not subject to rounding error. Now please understand, doubles might round 2.923, right? But remember, in financial calculations, even 0.00001 would make a drastic change in many cases. So if you think that such changes or rounding ups could create a drastic difference in the end result, it's best to declare your variable as a decimal data type. So variables of decimal are used in this book for financial calculations because the result should be exactly intact as it is, with all the fractions, without any rounding up or truncation. Okay. So how we can use this decimal in a given program? You can, now these are different ways of declaration. You can have dim A as double, comma, dim B as integer, and comma, dim C as decimal. You see, they all are separated by comma. So you can declare different variables in one line separated by comma. And also you can do declaration at the same time, initialization at the same time. So over here you see dim A as double equal to 2. So you're giving value 2 to A, value 5 to B, and value 1.05 D. Now this D distinguishes the value from double. Now when you have a D, just postfix to a value, you know that value is of type decimal and not double. So the only difference between double and decimal, beside rounding up, is that you have to put D just after the initialization of that value to represent that this value is of decimal value and not double value, because 1.05 could also be treated as a double. But since you write D, it indicates in the program that this value is specifically declared as decimal. Right? Now, we talked about parentheses. They should be used liberally in numeric expressions. In the absence of parentheses, the operations are carried out in the following format. You remember we talked about arithmetic precedences. So first you need to do exponentiation, multiplication, division, and that to first right division and then left division, mod, then addition, and then subtraction. So this is the hierarchy of operators precedences rule. So if you have in an expression all these operations, you have to go one by one and remember the precedence and take those expressions according to their priority and compute them till you get the result. Now, we talked about syntax, logical, and runtime error. These are the three kinds of errors which we normally commit. And we talked about them in details. Now, we have 1 minute left. So we have talked about these errors as such. So I stop at lecture note 21. And let me know if you all have any questions and we can discuss at this point. Anybody has any questions? Good. All right. So you all have a very good evening, and please practice all these programs. And let me know if you have any questions in the next class.